Properties of electric charge. So in the last class already studied what is electric charge. So what are the important properties of electric charge will be discussion in the today class. So let's start with the first one. You know very well charge is a transferable. Okay, so the charge is a transferable, but it is a quantized. So what is the meaning of quantized? So let's say charge is a transferable. Charge is transferable. Charge transferable, but it is quantized. So what is the meaning of quantized? So the charge, elementary charge value is equal to 1.6 into 10 to the power of minus 19. So that is the smallest charge is available in the nature. You know very well in the last class. So what is the meaning of quantized? The charge is quantized means the charge value is equal to integral multiple of elementary charge value. So integral multiple of elementary charge value. So where n is called as, where n is the integer, so that's value is 1, 2, 3, 4, 5 like that. So that means the charge value is possibilities is 1e, 2e, 3e, 4e. So that's the charge is when the transfer the charge from one body to the another body, it is not possible for 1.5, 2.5 like that is not possible. The charge is to transfer, so 3.2 into 10 to the power of minus 19 does. So this amount of charge is transferred from one body to the another body. Yes. Why? So because this is the charge is equal to 3.2 means how much? It is dividing by 1.6 into 10 to the power of minus 19. Cancel. That's value is 2. That means that is a 2 electrons is flow. So that is the what charge is quantized. Then second one, the basic property of charge, the charge is a additivity. So charge is a additivity means charge is additivity. So what is the meaning of charge additivity? So let's see. So this is the system. The system is mainly consisting for Q1, Q2, Q3, Q4, Q5 up to Qn. What is the total charge on this system? The total charge on this system is equal to algebraic sum of individual charges is present anywhere on this system. So individual charges means Q1, Q2, Q3 plus Q4 plus Q5. So why the algebraic sum? You have to what? Focus the positive and also negative charge. Okay, so for example, this is a minus Q3 is there, so you put minus. Okay, so this is called as what? Charge is a additivity in nature. How to total the charge on the system? Just algebraic sum of the individual charges present anywhere on the system. Then third point is basic property of the charge. Charge is conserved. Okay, so let's come to the point. Charge is conserved. Charge is conserved means, so do not thought like charge. So that means a charge is neither be created nor be destroyed. Not like that. Many of the students, the concept charge is a conserved means thoughts in like that way. That is a wrong. What is the meaning? How the charge is created and destroyed? Let's see. So when the two bodies are rubbed with each other, okay. So for example, so this is the A body, this is the B body. So A and B are rubbed with each other. So one of the body is losing the electron. Lose the electron. Okay. So this body is lose the electron. This body is gain the electron. Gain the electron. For example, 10 electrons are there. So initially this is also 10 because the neutral condition is like that. So lose the electron means, for example, 2 electrons are losing means it is 8. So this is gaining the electrons means 12. Now charge is created, charge is destroyed. Okay, so that is not possible. So what is this one concept? The total charge on the isolated system remains constant. Okay, so what is the total charge? The total charge on this system is remains constant. So 10 plus 10, 20. The total charge is remains constant. So that is what charge is a concept. So let's see the example. Okay, let's take the example for charge is conserved. How the charge is conserved? So takes one example. The process is called as pair of annihilation process. Pair of annihilation. So what is the pair of annihilation? When electron having charge 1.6 into 10 to the power of minus 19 is combined with positron. So positron means it is an antiparticle of electron having opposite charge. So this charge is minus the positron charge plus 1.6 into 10 to the power of minus 92 are combining with each other. So this is electron, this is a positron. So both are combining together or destroyed together. So we got that is a photon having no charge. So that is equal to this is electron combined with positron. So we got photon, no charge. So this is the process is called as pair of annihilation. It is the best example for the how the charge is conserved. So let's take the LHS side. Let's take LHS side. So LHS side, that is a minus 1 plus 1. What about the total charge? The total charge in the LS side, that is equal to plus Q minus Q. So then that is equal to 0. So in RHS side, the charge is equal to 0. The total charge, that means in the isolated system, the charge is remains same. So let's take the another one example, that is called as pair of production. So what is the pair of production? The reverse process of pair of annihilation. So annihilation process is already studied. Okay. So what is the pair of production? So pair of production means, so this photon is produces electron, a positron and electron. Okay, so this is the process is called as pair of production. So this is the best examples for what charge is conserved. Okay, the three basic properties of charge is studied. Okay, let's take, that is the next one is the auxiliary properties of the charge. The more properties of the charge is studied one by one. The first one is that is an auxiliary properties of charge. First one, so the charges is resides on the outer surface of the conductor. So for example, this is the conductor. You have to apply the more charges. You have to providing the charges from the external agency. Those external charges are resides the outer surface of the conductor. The charges are not to what go to the inside of the conductor. So that means the charges resides only outer surface of conductor. The residing of the charges of the conductor, it depends upon the radius of the surface of the conductor. If the radius is uniform, it is the uniform shape. So the charges are distributed uniformly. So if in the irregular shape of the body, so this is the irregular shape of the body. So in this irregular shape of the body, the charges are more in the less curvature. So this is the curvature is less. This curvature is less, the more charges are present. So this is the curvature is larger. So larger curvature, the less number of the charges are resides. So in case of irregular body. So in case of the regular body, for example, this is the regular body. In this regular body, the charges are distributed uniformly like that. So this is the one more property. Then, so another one property is charges is always associated with mass. Okay, so that means the charge is always be associated with mass. So without mass cannot charge is there. But mass, so mass is there without charge. Okay, so the charge is always associated with, the charge is always associated with mass. But mass is not associated with charge. So then one more important point is charge is unaffected by the motion. So how the charge is unaffected by the motion? That is another one. Charge is unaffected by the motion. So if the charge is, let's take the charge value is equal to 10 coulomb. So this charge is rest condition. Its magnitude is 10 coulomb. So now the same charge is in the motion condition. So with the same charge is motion, the magnitude remains the same. Does not impact on the magnitude of the charge. If the charge is rest condition or if the charge is in the motion condition. Okay, so that means the charge is unaffected by the motion. Its magnitude does not impact when the charge is rest condition or in the motion condition. So this is the what is so it is a auxiliary. So properties of the charges. Okay, let's see one more chart. That is, so amount of electric charge does not depends on the frame of reference. Okay, you are as I said in the first year. So frame of reference, you know the concept of frame of reference. So but in the electric charge, it does not depends on the frame of reference. So it is a very important point. Charge is electric charge is independent of frame of reference. Okay, so then who is invented charge is quantized? The great scientist Millikan's all-drops experiment. From that experiment, the conclusion part from the electric charge is the charge is a quantized and also it is a transferable. Charge is the independent of frame of reference. Okay. So there are two categories of charge. Okay, so two types of charge. The first one is positive charge. Who is invented the two types of charge? That is, so Benjamin Franklin is invented the two types of charge. Positive charge. Another one is negative charge. So like charges are this is a like charges are repulsive. Unlike charges are attractive. It is also like charges. Repulsive. Okay. So then one more important property. The ratio of charge to the mass ratio. The ratio of charge to the mass ratio, that is called as specific charge. Specific charge. The ratio of charge to the mass is called specific charge. Specific charge ratio. So the specific charge ratio of electron, for example, specific charge of electron. Specific charge of electron is equal to charge by ratio. What is the charge of electron? The charge of electron, mass of electron. Charge of electron is 1.6 into 10 to the power of minus 19 divided by. So what is the mass of electron? 9.1 into 10 to the power of minus 30. So we got 10 to the power of 11. So that is answer is 9.1. That is a point to point get cancelled. 16 divided by 91. So 0. Okay, so that is the answer is equal to 1.76. I think. Okay, so 1.76. So 1.76. This is a kg divided by mass. Charge is coulomb divided by kg. Okay, so this is the properties of the charges for up to NEET and mains level.